Good morning. I see some of us survived last night, so that's a good thing. And the first question is, do you love my lovely art? Anyway, that's not really mine, but I stole it from my publisher. Okay, so what's this talk about anyway? I just wanted to give you guys a little bit of a talk about determining with some certainty if you've been hacked. So you have a Linux system, someone calls you, and you want to determine if they've been a victim of some sort of attack in a few minutes' time with minimal disruption and disturbance to the subject system. You don't want to contaminate all the evidence. And also, how can you automate this process with some shell scripting? Right? So you might ask yourself, why should I care? Well, someone calls you, you need to be able to make a pretty quick determination in order to avoid further harm. You want to figure out, did someone hack them or not? You want to do this without destroying evidence. And you want to do this without taking down a critical machine. It might be easy to take down the machine and go right to some dead analysis, but it would be rather embarrassing if you did that on a production system and it turns out nothing actually happened. Or as you might hear, suddenly nothing happened. Right? Now, some of you might wonder, who is this handsome man? I'm a digital forensics professor. I teach at Bloomsburg University of Pennsylvania. I've been programming since I was 8. Kicked it up a little bit, programming in assembly since I was 10. I've been known to hack electronics since I was around 12 or so. I've been using Linux for quite a while. I was in graduate school, and I had a friend of mine that said, hey, Phil, there's some guy is making this PC Unix, you should check that out. Right? And also an author. I've written a book. I wrote a book last year that I know some of you own on hacking and penetration testing with low-power devices. It's basically how can you make small battery-powered devices for pen testing from up to 2 miles away, and you can network them together and all that. Also recently published a book on Linux forensics. And my favorite is this guy over here with the please insert cool cover art. This is in process, so probably the end of this year, a book on USB. All right, so what are we going to talk about? We're going to talk a little bit about opening a case. How do you do that? Talking to users, mounting some known good binaries. How do you minimize the disturbance to your system? How do you collect data? What should you collect and why? How can you automate this with some shell scripting? And some next steps if you say, yeah, you've been hacked. All right, so opening a case, it's not really that big of a deal. Decide on a case name. If you're not sure what to name your case, the date might work unless you have multiple cases a day. If you have multiple Linux systems getting hacked every day, you should probably hire more people, I don't know. Or you might have better preventative measures. So you probably want to create a folder on your laptop. And the other thing that I suggest people do, a lot of people think this is strange, but I say get yourself a bound notebook like one of these, preferably with numbered pages. If it doesn't have numbered pages, you can number it before you start using it. And why would you want to do that? Right? A couple reasons. A notebook is very easy to carry. It is hard to insert or remove pages. So if some slimy lawyer, I know you guys have never seen a slimy lawyer, but ever tries to accuse you of tampering with things or altering your notes, you can say, well, I didn't put something in here and I didn't rip a page out. So there's that. And also, it doesn't require any batteries. All right, so you got a call. And you've shown up on the scene. You opened your case. You created a file, a folder, and you have your notebook. Now what do you want to do? Well, the first thing you want to do is you want to talk to the users. Why? Well, they know the situation better than you do, number one, and you might be able to figure out that it's a false alarm before you start digging in. Maybe someone internally was doing something. Maybe one of the admins put something in promiscuous mode, etc. I actually got an email about a month back from my university. Someone said, "Phil, have you been doing any," in quotes, "pen testing on our network?" It's like, no, I haven't even been on campus or touching that network for a couple months. So, things like that where you can figure out if somebody just did something by mistake or maybe something they shouldn't have done, that can save everybody a lot of trouble. The other thing that I like to do when I talk to the users is ask them, why'd you call me? What do you suspect has happened here? And also, not just why did you call somebody, why did you call me? Do you not have any internal experts, or perhaps you have some sort of organizational policy that requires you to use an outside investigator for things like this? And then from there, you can ask questions like, why do you think there was an incident? And tell me everything you know about the subject system. Is it a developer's workstation? Is it a web server, file server? What is this machine? And what is it typically used for? What users would normally be logged in to this machine, etc. Basically, it's kind of getting a baseline without doing anything technical yet. Right? So now you're finally ready to think about touching this computer. So what are you going to do? You should have in your toolkit a USB response drive, and this response drive should contain some known good binaries. Now, in most cases, you need some 64-bit binaries. I suppose you could have some backup 32-bit binaries. I don't know who is still running 32-bit Linux in 2015. But maybe there's somebody out there that's still doing it. So what do you want? At a minimum, you want bin and sbin, right? For the same architecture. Don't get it for 32-bit or ARM or MIPS or something weird. But get something very similar. You might also want to grab sbin and bin out of user if you want some extra tools. And it's important that you put this on an X file system, X2, 3, or 4. Any of those should work for the situation. Biggest reason you want to do that is for permissions, right? You can't put it on a fat partition and then mount it and say, all my system binaries are on a fat partition. And it's going to say, I don't like that at all, right? It's not going to allow you to execute those in the normal way. Now, you could also have a bootable version of Linux on the same partition. That partition is probably going to have to be fat, and then you're going to say, but Phil, you just said it has to be extended. Some of you probably know that on those live Linux systems, yes, you have a fat partition, but you have a squashed partition inside of it that's mounted or formatted as something else. If you do have a bootable Linux, you should put that on the first partition, because if it's not on the first partition, a lot of machines will not properly boot it. And by the way, some of you probably already knew this, but Windows is pretty dumb, and it doesn't see anything past the first partition on a thumb drive. So if you have a thumb drive with multiple partitions, you can format the additional ones with a Linux file system. You can also encrypt them, and on top of that, if someone plugs it into this Windows machine, they're never going to see it. There is a little video that I made. And here's the link. It's at linuxforensicsbook.com, which is a support site for this book that we just published. It's like the chapter 1 video. And basically that video, for anyone that's interested, will walk you through how can you create a response drive by forcing VirtualBox to boot from an actual physical USB, right? And that has a nice advantage that if you have a USB drive and you want to set up something like SIFT or some other forensics-oriented Linux, it can take a long time, right? So you don't want to tie up your workstation for hours while it's downloading packages for this. Instead, you can set it up in a virtual machine and you can do other work. Right. Okay, so as I said, one of the first things you want to do, you want to take that response drive and you want to load your known good binaries. So what you want to do is insert that response drive, and then you need to exec your bash binary. Then you want to set up your paths so that everything is pointing to your binaries and only your binaries. And then you also need to set your LD library path so that your shared libraries get found. Another thing to note, run all your shell scripts as bash plus the script name. Don't have scripts that start with the standard shebang, right? Because the standard shebang is going to point where? To the bad binaries, right? So, you know, be careful about that. So here's kind of how that goes.
So I have my subject system here. Now in my case, it automatically mounted the volume with my binaries. This is not always going to be the case. Depending on the version of Linux that you're running, some of them will not auto-mount an extended file system. But in my case, that did happen. So I can see it's here. I can go to that directory. So I can cd to media, John. So the very first thing you want to do is to exec your known good bash, like so. And now you have to set your paths appropriately. I recommend that you use this little trick where you can put a command inside of parentheses that follow a $sign in order to substitute them into whatever you're doing, like so.
Don't you wish you typed this fast?
Your library path. So now you should be all set. You can do a quick test, and that seems to be working properly. And you're ready to start your investigation because you now have a known good bash shell with known good binaries.
All right, so some of you might guess I don't really type that fast. Okay, so now you have your known good binaries loaded. Everything seems to be working. What do you want to do next? So now you want to, try to minimize the disturbance to your system. You're always going to change things a little bit, but hopefully not anything significant. You want to minimize your memory footprint. And you never, ever want to write to the subject's media. And there are two basic options that you have. Option one, you can save everything to your USB response drive. And option two is that you can send it over the network. So let's talk a little bit about that. Sending data over the network is preferred. It's better than a USB drive because of caching mostly. Now, if you know anything about USB, you know that the write times are horrible, and so it's heavily cached. So of course, all that caching is going to occur in memory, and that's going to corrupt some of your memory image that you might want to use later. So I recommend that you use something like Netcat. So what you want to do is you create a listener for what I call log type information on your forensics workstation. And then you send that log information from the client. And also it would be nice to create a way to be able to send files. You know, maybe you see a suspicious binary or some other file that you want to have. So, you know, I'll show you a pretty simple system where you can spawn a new listener that listens for files. So how do you set up, oops, there we go. How do you set up a log listener? It's pretty easy. Just run netcat. By the way, you can run netcat or nc. It's usually aliased as the same thing. -K, which tells it, please keep alive. You know, normally netcat listens, it gets something and then exits. -L, hey, please listen. And then I give it a port name and then double greater than sign to append to some sort of file. And then from your subject system, you just run a command, pipe it to netcat, and then your forensics workstation's IP, and then whatever port you used. So it's pretty easy. Of course, it's easy, but we'll still automate it using shell scripting. Now, why not Python? That might be a good question to ask. Again, the biggest reason not to use Python is that Python's a little bit more heavyweight than a shell script. So using a shell script allows you to not have to load as much stuff up into memory, which is going to minimize that disturbance and that footprint on your subject system. So if you want to automate this, here's a pretty simple little script, and it's called start case. So you start up a case, and you know, you can see here that I have a usage, a pretty simple usage, and then I check to see if you gave me any parameters. I want a case number, and if you didn't give me that, then I'll give you my usage. Otherwise, I'll just say I'm starting the case. If the directory for that case doesn't exist, I'm going to create it, and then I'm going to create my log listener process. Again, using this construct I just showed you, nc-k-l, and then a port, and then appending to a file. Oops. And then I will start my file listener here. And that's another script. I'll show you that in a little bit. On the client side, it's pretty simple as well. So what you want to do is first, you want to set up the client. So here I have a pretty simple file where you can, again, there's a usage statement, but you can see from the usage. By the way, you can download all these scripts off of that same website, linuxforensicsbook.com. I've abbreviated some of these, so I normally would have more comments, but you know, I thought you might prefer a legible font size to extra comments for this. So you just give it the IP address for your forensics workstation, the port that's being used for logging, the port that's being used for file names, and the one that's being used for actual data for the files. And of course, these are all optional. You really only need to have the IP address, and everything can be defaulted. And then if you don't give me a file, I'm going to complain, and I will export all of these things. So yeah, this is the world's crappiest but most straightforward bash script here, right? If you didn't set something, then I'm going to set it, etc. So once you've set that up and you set up these environment variables, then you want to send some information. That's pretty simply done. So we have some defaults primarily for testing purposes. It's going to say, hey, are these environment variables set up? If not, go ahead and set them up. Again, there's a usage statement that's going to tell you it's run the script and then give it a command to execute. And all it's going to do is echo that command. Well, first it's going to put a little banner, then it's going to run your command, and then it's going to echo a little closing banner onto your script. All right, so that's what's going on here in this somewhat messy looking line. Right? Now, we said that it'd be nice to have a way to send files as well, and that's available. So we have a listener on the forensics workstation that listens for a file name. And as soon as it receives a file name, someone says, I'm going to send you a file. It's going to create a new listener to receive the file, to receive the actual data, and it's going to redirect the file to one with the correct name. And it's also optionally going to log in the main log file that, hey, somebody sent me this file at this time, so that I have it in my notes. On the client side, I send the file name after a little bit of a pause to make sure that this new listener has been created. Then I will send my stuff. So what does this look like? It's pretty basic. So here is the file listener on your forensics workstation. And again, you can start it up and make sure that you give it a case number or case name. This is automatically called from that other script I showed you a little bit ago. And it will start a listener by default on port 5555. And as soon as it receives something, this line here will exit this line. And then it will call this one, which creates a new listener. Now notice here that I'm not using the -K, right? Because I don't want these guys to keep alive. I want it to start a listener listening for a file name. As soon as it gets a file name, it creates a new listener. And once that's done, it goes back in my infinite do loop here, and it will create another name listener. And then once a file name is received again, it'll drop to this line, and that will continue. And it works pretty well. On the client side, again, I set up defaults if you haven't given me stuff. And I have a basic usage. If you give me a file name, I'm going to log it. So I'm going to echo the appropriate information to my log listener. And then I'm going to echo my file name to my file name listener. Give it 5 seconds just to make sure. You probably don't really need 5 seconds, but it's better to wait 5 seconds and be sure. And then I use netcat to send the file. So I take whatever file you passed in and I send that to the actual file listener, and that's it. It's pretty much done. It's good to clean up. Your mom would be proud of you if you clean up after yourself. So when you're all done, this is just a simple little script to run on your forensics workstation to clean up that will kill all those listeners, and it will also log in your log file again that, hey, I just shut down at a user request. Okay, so let's talk about data. So you want to collect some data. Well, what do you want to collect and why? So one of the first things you want to collect is the date. Might seem kind of dumb, but you want to get the date and time in order to detect a couple of things. Is there any clock skew on your subject system? If it's not connected to a time server, it's quickly going to drift, and that might skew your results. Is it in the same time zone? What's the kernel version? So you can use, uname-a, and it will tell you, you need to know it, first of all, if you're going to use volatility. How many of you use volatility? Right. Volatility for Linux, how many of you used? For a Linux subject, not just, okay, a couple of you. Right. It's not quite as nice as for Windows subjects, is it? Yeah. But let's be fair, a couple years ago, could you do it at all? No, so it's an improvement. Might not be 100% reliable, but so yeah, you want to get the kernel version. As you know, if you've used volatility, you need that in order to do your memory analysis later. It might also be useful for researching vulnerabilities that might be present on the system. You might say, oh, I know that this kernel version had a problem, which of course never happens because Linux is perfect and has no issues. Okay, so collecting data, some more other things. You want to collect information on the network interfaces. So you can do it in ifconfig-a, and why would you want to do this? Are there any new interfaces? Did someone plug in an extra adapter, maybe a wireless adapter of some sort? Are there any strange addresses being assigned, something that's not in your normal network? You want to look at network connections, of course. So you can run something like netstat-anp. And, are there suspicious connections to addresses? I actually had an issue this week where I had some students back in the US. They were asking me, hey, I screwed up. Could you go out to our online system? Could you reset something for me so I can resubmit an assignment? Apparently, the answer would be no, because my university doesn't like students from the UK. So I was blocked from being able to authorize, anything from here. But so, are there connections from suspicious countries like the UK, right? And are there any strange localhost connections? You can do a lot of things on the localhost interface that is usually not monitored by IDS systems, right? So you might try some things, and they're fairly quick. They're not really limited by the hardware so much. Are there any suspicious ports? Are there any programs that are running on the wrong ports, or perhaps with the wrong user? Oh, our web server is being run as root. Nobody does that. FireEye. But, I didn't say. Okay, other things that you want to collect. Open files. You can do an LSOF-V, give you a nice verbose output. So what programs are using certain files and ports? This might fail if you have malware installed. So whenever any of these fail, you should immediately start becoming suspicious, right? So when you look at the output for these various commands, if they output nothing, that's extremely suspicious. And if they have two commands that have similar information that don't have the exact same results, that's also cause for alarm. Of course, you want to look at running processes. So you can do a ps-ef and or ps.-aux. Are there things that are running as root that shouldn't be? Are there login accounts that are running things, but they're accounts that aren't supposed to be able to log in? And again, this might easily fail if you have malware installed. I mean, do you think that the ps command often fails? So if the ps command doesn't work, I'm going to be very suspicious. That's the nice thing about Linux users, right? Windows users, funny things happen. They're like, right? Linux user like, someone has hacked me. Something has happened, right? Collecting data. All right, routing info. Again, use multiple tools, netstat-rn and route. They will go to slightly different structures in the kernel, and you want to compare the results. Is there anything routed through a new interface? Are there any new gateways? Are there conflicting results? Is there a failure to run? These are all indications of malware. All right, collecting data. Mounted file systems. Look at mount and look at DF. You know, are there things, again, that are mounted that shouldn't be, especially temporary file systems? By the way, a little tip, be careful if you go to Google Images and you search for mounted, you might see some really sick things. That and autopsy, don't search for those two things unless you've already had breakfast, etc. But, you know, are there some mount options that have changed? Has something been mounted writable that shouldn't be, etc.? Now, of course, temporary file systems can go away when the machine is shut down. So you could easily hide some things by creating a temp file system and putting a little bit of data in there. Is your file system filling up? Is there a disagreement between these two commands? Again, disagreements usually indicate malware. You want to look at kernel modules with lsmod. Are there some nice new device drivers that shouldn't be there? Any modules that have been changed? Other things you want to look at. Who's logged in now? You run the W command, which is similar to who, but it tells you what they last ran. Again, are there system accounts that shouldn't be allowed to log in that are logged in? Who's been logging in recently? This is the last command. So again, people logging in that shouldn't be. Are there accounts that don't normally access this particular machine? Again, this is where interviewing the users is helpful at the front end. What about failed logins? Last B will give you failed logins. Now, if you see repeated failures for an account followed by a successful login, what does that look like? Cracked password, right? You see someone 50 times failed to log in as a certain user, and then they got in, and you can see there's a successful login for that user, which means that their password is in the top 50 list, right? It's like, it's not a good thing. You're gonna have a talk with somebody about that. User login info. You want to collect the password file and the shadow file. Is there any newly created logins? Are there any system accounts that have shells and home directories, things that, again, normally aren't supposed to be able to log in? Anyone have an account with an ID of 0? Right? At an organization where I once worked, I had an admin ask me this question one day, and he's like, Phil, do you know anything about this account? Apparently, in their domain, not just on a machine, but in the whole domain, there was a new account created. You know, it was like the no one account or something. And from what he told me, not that I know any details about what actually happened here, there was a new user with an ID of 0, which of course made them root on the entire network. So he asked me if I knew anything about it, and of course, I knew nothing at all about how this may have occurred, because this is a recorded talk after all. All right. So are there any accounts that have passwords that shouldn't? Right. So those are the kinds of things that you want to collect. So you want to put it all together with a script, of course. So all this script does is calls my other script called sendlog, and it runs all these commands that we just talked about. And it looks kind of like this.
So one thing that you'll notice right away is that I have all of my scripts on my response drive. So I can go ahead and start things up on my forensics workstation. So here on my forensics workstation, I can start a case like so. If I do a PS, I will see that I have some listeners that are already set up. If I go back to my subject system, I will see my setup client script. I can source this and pass it the IP address. And now I can simply run my initial scan script. And that's it. It's already done. Now, I notice that the last command is not really giving me a lot of data. And there's a couple reasons why this can happen. Now, in my case, it's actually because I'm running the system months after it was originally created and set up. So one thing you can do in order to fix that, if you go to var log, you will see WTMP and WTMP.1. Same thing with BTMP. And if you do a quick help on last, you will see there's an option to give it a file. So you can do like so. And you're going to get quite a bit more information. So all you need to do is run that with send log. And the same thing can be done for last B. And now you're ready to have a look at the log files that you collected.
All right, so now you're starting to look at these log files and trying to answer again, the question is, have I been hacked or not? So here, you'll notice that when I run netstat and lsof, what do I get? Nothing, right? And what does that make us suspect? Malware. When I look at the password file, you can see here, there's a new guy in town. His name is John with 2 N's. And it appears as though someone tried to make him look like the other John Smith, right? You notice that they have the name as John Smith. Now, of course, John Smith is a common name, but this is a new account that shouldn't be there. If you look at the shadow file, what are you going to see there? So looking at the shadow file, I see Whoopsie has a password, and I see that LightDM has a password, which is kind of odd, because what's LightDM for? Display Manager. Should that have a password? Probably not. So that's a little bit suspicious. So from there, I'm going to look into my log, and I'm going to say, who's been logging in? And I see, sure enough, John with 2 N's has been logging in. Also, LightDM has been logging in remotely even. Right? And again, I see multiple logins from John with 2 N's. So then the next question is, who's failed to log in? Well, surprise, surprise, LightDM has a failed login, which again leads to the question, why are they trying to log in anyway? This is a system account. So I'd say it looks pretty likely that you've been hacked in this case. So now what do you want to do? So, you got the call, and pretty much we've gone through, this is my high-level process for doing a forensics investigation. Yep, there was an incident. So now the question is, we want to do some limited live analysis. We did a little bit of live analysis just to make that determination, but you probably want to do a more thorough live analysis. And then you can ask yourself the question, am I going to do some traditional debt analysis? It's a lot more mature and powerful, something we've been doing for a really long time. But sometimes you just can't afford to take that system down. So if you can't afford to take that system down, you might have to do something else. So, If you're going to do the dead analysis, you can acquire images. You know, by the way, you can acquire an image on a running system. It's just, it's not as good, but you can do it. And of course, you want to always write your reports. Our favorite part of anything, pen testing, forensics investigations, all the same. We love to write reports around here. And of course, we want to document any lessons learned, regardless of what happened. So live analysis techniques, you want to use kind of what we talked about here and maybe grab some more stuff, grab some metadata from those files, especially things like sbin and bin. Grab the user's command histories. Grab some system log files. Get some hashes of suspicious files so you can compare them to the database. And then, of course, you can dump some RAM. Now, dumping RAM on the Linux system, you need to compile a program called Lime, the Linux memory extractor tool. Whatever you do, remember, don't compile it on the subject system, right? Remember we said minimum memory footprint. We said don't touch the media. Yeah, let me compile this kernel module. That won't touch anything, will it? Right, so you want to do that off of the machine. Again, if you go to linuxforensicsbook.com, some of the scripts that are in that book will show you how you can create a profile for volatility and how you can build it pretty easily off the subject system. Also, something you should be aware of, it is a little bit risky to dump RAM. You could cause a crash. I guess in that case, well, you're down now. But those of you that saw the JTAG talk yesterday probably heard a couple of times, yeah, it doesn't always restart, right? You stop something, use JTAG. You know, similar thing here. You know, you might try to dump some RAM, might be successful, might crash, who knows? I usually have pretty good success actually with Lime that I've compiled elsewhere, but your mileage may vary. Or is it your kilometerage? That's an interesting question. I mean, I know you guys use miles here, but elsewhere where they use kilometers, they still talk about mileage. I don't know. Okay, so dead analysis. Unless that you absolutely cannot take down the machine, I really do recommend that you try to do some dead analysis. Again, it's just so much more mature, and there's so many more tools out there available to you. Now, if you cannot shut down that machine, you can still get an image if you use DCFLDD. For those of you that are not familiar, I'm sure most of you are familiar with DD. It's a really old Unix, now Linux tool for pushing bits around. By the way, does anyone know what the original use of DD was for? EBCDIC conversions to ASCII. Yeah, I looked that one up, little factoid there. So there's a couple of folks that made a forensics version of DD. It's called DCFLDD. There's some others out there as well, but one of the features of DCFLDD is that it will do hashes as it captures, and it can be used on a running system. It's not ideal again, and you probably can't use that evidence in court based on that, but let's be honest. If someone hacked you, what are the chances of you being able to prosecute them anyway? You know, you had to find them, and if they're in another country, it gets a little bit complicated.
Korea.
Oh yeah. Again, you know, the U.S. We're good about that, right? It was China. No, it was Korea. It's Korea's turn, sir. Okay. We'll attribute it to them today. But so yeah. Now, dead analysis, of course, like I said, there's a lot there. It's a lot more powerful and mature. The Linux support for volatility is a little bit lacking. Again, to be fair, a couple years ago, couldn't do it at all. And the Linux support is relatively new. Now, what I've seen is that if you're running any kind of a recent kernel, and I don't mean just a 4 kernel, if you're running like a recent, say 3.16 or above kernel on your Linux box, a lot of the volatility modules, unfortunately, seem to fall down. Right? There's some of them that just don't work, some of them that crash, and there's a couple of them, there's one that I tried to run for a video that I was making, and after 3 hours, still not done, and just it's a new area for us. The other thing I would say is, I know a lot of forensics people because I teach in a forensics program, but I have never seen anybody that said, I found something that was only existing in memory. There was absolutely no evidence of something on the file system as well. So, given that the file system forensics is a little bit more mature, it might be a good thing to have a look at the file system's image, again, if you can. So where can you find out more? I heard that there was a new book, might look kind of like that. And there's also some resources out there. Again, if you go to the support website for the book, you can get all the scripts from the book. It's all open source, right? So there's a lot of Python in there. So there's Python for parsing ext4 file systems. There's all these scripts that I talked about today. Feel free to come talk to me later. And with that, do you have any questions?